Okay, let's now have a quick recap of simultaneous equations. Another important skill we need. Most popular method, I think, is what we call the elimination method. So the idea is we want to eliminate a variable out of our equations and then go and solve for the other variable. And then once you've solved for the other variable, you can substitute back in and find what the eliminated variable is. So that's the basic idea of what we call the elimination method. So here's a typical sort of simultaneous equation. Before we can do an elimination, we need to make the coefficients the same. Now, it doesn't matter which one we do. It can be the x, it can be the y. As long as one of them is the same, then we can eliminate it. I wonder which one I picked, the x or the y. Let's see. So I've decided to multiply the first one by 2 and the second one by 3, making the coefficients of y the same. Okay, so I've made them both 6y. Can do a subtraction then, and the y's will eliminate or disappear. Notice I've actually subtracted the top from the bottom, not the other way around, because I just prefer positives. So I've ended up with 11x equals negative 33. X is negative 3. And I can substitute back into any of the four equations. It doesn't matter which one. And it works out to be y is 9. When I'm writing my answer down for this equation, or simultaneous equations, I actually write it down as x equals negative 3, y equals 9. I don't write it down as a set of coordinates. Okay? Yes, we use this technique to find the point of intersection of lines. And if that was the question, all right, then I'd write down the answer as the point minus 3, 9. But that's not what this question is. It just happens that the pronumerals I'm using is x and y. So we have an answer for x and an answer for y. Now, unfortunately, this one I can't do by elimination. Because if I want to make the pronumerals the same, I might multiply the top one by y and I can get rid of the y squareds, but now I've got a 2xy, so I haven't really solved the problem. So this is where we use the substitution idea. So I'm going to make y the subject in the top one. You can pick any of the pronumerals to make the subject. It doesn't matter. But make life easy for yourself. I'm not going to make y the subject in the second one, because that will then end up with y is the square root or something. So that would be a silly choice. So I could have used x or y, but seeing I've already got one y on the top, it seems the logical one to pick. So it becomes y equals 14 minus 2x. We then substitute that into the second one. So I've got x squared minus 14 minus 2x all squared. That is 9. I've got a quadratic equation to solve. Expand the whole thing out. Gee, it'd be nice if 3 went into everything. No, it doesn't, does it? 3 doesn't go into 205. So what multiplies together to give 615 adds together to give negative 56. Oh, of course, yeah, right, okay. There we go. 3x minus 41, x minus 5 for our possibilities there. So we actually have two solutions. And that makes sense, because we're not talking about, if we do think about coordinate geometry, I'm not talking about two lines intersecting here. The top one is a line. The second one, anyone know what the second one is? Yeah? It actually is a hyperbola, but not the way we're used to seeing it. It's on its side. So it makes sense that there would be two solutions. The line would cut that hyperbola twice. Let's find those y's. And again, let's write a final answer where I group the solutions together. So either x equals 5, y equals 4, or x equals 41 on 3, y equals minus 40 on 3. They are the two possibilities for this equation. Well, there's no reason why we have to stop at 2. Any time you've got the same number of pronumerals or unknowns as you do equations, it's theoretically possible to find those pronumerals. So long as one of those equations is not a multiple of one of the other ones. If you have 3 different ones, it should be possible. Going to use the elimination idea. So I'm now going to create 2 pairs of 2 equations, but I'm going to eliminate the same variable from both. So here's what I do. I'm going to get the first equation, multiply it by 2. And then I'm going to pair that up with the second equation, and you'll notice the x has the same coefficient. I can do a subtraction. It eliminates the x. Now I'm going to pick another pair and make x the same. So I'm going to get the first equation, multiply it by 4, match it up with the third equation. Coefficients of x are the same. And do a subtraction. I now have two equations, two pronumerals. Our standard sort of simultaneous equations. So I will now do that. So I've made the coefficient of z the same. So I've multiplied the 3y minus z equals negative 10 by 6. I can now eliminate the z. And I end up with y is negative 2. And now I can work my way backwards and find all the pronumerals. So y equals negative 2, subbing into one of our second equations we created. I get z is equal to 4. Now sub those two numbers into one of the first three equations, and I get x is equal to 3. And so there we go. X equals 3, y equals negative 2, z equals 4. If I was to translate this into coordinate geometry, we're actually talking about a three-dimensional space, because you have an x-axis, you have a y-axis, you would also have a z-axis giving you 3 dimensions, and you have 3 lines in 3 dimensions, and they would also meet at a single point, and that would be the particular point that they would meet. There. 3 asterisks on number 9? Ooh, that must be a good question.